Welcome to another Tech Innovator podcast series presented to you by the ICT Tech West Sri Lanka. Tech Innovator is our podcast series in which we discuss various cutting-edge technologies and explore their uses and advancements with industry experts. I'm Samadhi Rajapaksha. Today with me I have Mr. Pirus Siriyankan, who is Engineering Manager at Brickle, also Space Generation Advisory Council National Point of Contact for Thailand. Hello, Mr. Pirus. Welcome to the Tech Innovator podcast. It's an honor to have you with us today.
Hello, Sami. It's my honor too to be here as well.
Okay. Space ICT is known as Space Information and Communication Technology. Refers to the application of advanced technology in space-related activities. It involves the utilization of information and communication technologies for various purposes, including satellite communication, space-based navigation systems, remote sensing, and data analysis. When we hear the term of space ICT, this is what we generally think of, but I'm sure you have a better explain. So could you please explain briefly what is space ICT and how it has revolutionized the way we explore and understand the universe?
Okay, yeah, sure. So space ICT or space information and communication technologies. So basically, as you already mentioned, is the systems technology that's used to collect, process, and analyze the information. And of course, as it is space ICT, so it's going to be information related to the space. It could be space operations or observation. So, what are we using space ICT as the utilizations we are using right now is in a lot of areas. Like first of all, basically communications, satellite, spacecraft, everything. They use space ICT to communicate all this real-time data transmissions between Earth and could be satellite spacecraft, and all this data could be compiled for the data analysis. Let's first go through some example of telescopes or remote sensing, of observations. We use all this kind of data to process, let's say, for the Earth observation on the forest fires could be happening on the Earth, or even the telescope that looking into deep space. And of course, for the space ICT, we can see all the services that could be surrounding the space ICT. Let's take a look of the things that we have on our phones on everyday uses. GPS. We can locate ourselves by using the space ICT technology. And I think there's a lot of future to be seen for the space ICT.
Yeah, perfect. Could you share some example of how space ICT has contributed to scientific discoveries and breakthroughs in fields such as astronomy and astrophysics?
Okay, sure. So focusing on astronomy and astrophysics, I think we can see that they have greatly contributed into numerous of scientific discoveries. Let's say, for instance, Hubble telescope or their successor James Webb telescope. This enabled by space ICT has provided the high resolution image of our universe, leading to the breakthrough in our understanding of galaxies, black holes, and even dark matters. All of these things that we have as a theories, we can prove that by using the space ICT of this kind of telescope. I think another good example is the space-based remote sensing, or for studying of the Earth climate patterns and monitoring environmental changes. For instance, GRACE, the gravity recovery and climate experiments, that have allow us to measure the change in Earth gravitational field and gain more insight into the movement of rockets masses or even IG.
Thank you. Satellite communication is one of the most important applications of this technology. Could you explain the process of satellite communication via space ICT to our listeners?
Yeah, absolutely. I think this is really important. I know there's a lot of application and usage of how we take use of space ICTs, and the most important is how how can we make it happen, right? How do we make it work? So basically, the satellite communication is a key component of the space ICT. Like the processes involve like the transmissions and receptions of signals like to and from a satellite. So basically, here on Earth, when we want to communicate back to the satellites in outer space, we will need to have a ground station. The ground stations basically they're going to be the place that we can send the signals of command. We call it uplink, and the satellite will receive the signals and verify them, share the frequency, and then like send it back to Earth via downlink. So yeah, this signal like can be received by ground stations or like could be at the receiver as well. So like this form of communication allow like for the data transmission and over long distance across barriers. So it's kind of how we communicate back and forth. It's how we use the satellite communication.
Yeah, perfect. What challenges do scientists and engineers face when developing and implementing space ICT systems, and how are they overcome?
Okay, the challenges of the space ICT systems. This actually is a really pretty good question. So as we develop more of like technologies, and of course we have like more satellites, and it's like from like all around the world, like every country tries to develop their own technologies on the space ICT systems. And of course, even though this contributes us into more advancements of technologies, it faced some challenges as well. So as we grew more and more of like satellites and aware communications, there's gonna be like some technical issues. They're gonna be we're gonna need more concern on this, like signal loss. Of course, when we have more satellites, it's gonna cause like more interference between the signaling. And when we go, let's say, more further into deep space, like outer space, when we go to Moon, to Mars, there's going to be the questions of latency, because we still have constraint when we communicate back and forth between, like, let's say we're going to send command to the spacecraft that traveling to Moons or Mars. You're going to have like more and more latency when we reaching that destination. And not only the communication wise, but also the condition of the space itself. Let's say for the extreme temperatures and cosmic radiation, that's gonna affect the hardware itself. And of course, I talk a lot about like issues that could be happening when we facing these space ICT systems. But like right now, the engineers, they're also like working the way to overcome this. We have like working on like more S01 materials that could prevent radiation. And of course, like when we communications, when they have interference, we also develop more of the advanced algorithms that could like enhance signal processing to prevent any signal loss or unable to communicate. and lastly, I think we need to come back to that we need to cooperate together all around the world. I think right now there's a lot of let's say a lot of like bodies that they do regulatories and try to ensure that we're gonna use this space like more effective. Like let's say like UN USA, for example, the UN Office for Space Affairs, and of course like ITUs, they're trying to play their roles on the regulation, so we can take the use of this space like in the most effective way.
Well, what are the latest developments in space ICT regarding the data transmission rates, satellite miniaturization, and the potential for improved communication networks in space?
Actually, there's quite a lot. So if you're talking about the data transmissions, satellite miniaturizations, I think one good example that we can see right now probably going to be the SpaceX Starlinks. So we used to have like big satellites orbiting around space and communicating back to Earth. But let's take like SpaceX Starlink for example. They create their own constellation with like smaller satellites. And with smaller satellites, it provides like more global broadband coverage. I think this is a really good example, like how we taking use of the satellite miniaturization, and of course when we seeing this, is also like better. I would say like the democratize of the space it by itself. So when we, let's say, get easier to put things up in space, it doesn't need to be a big chunk of satellite anymore. The satellite becomes smaller, become like, let's say, taking less cost to deliver something to space. So they provided more opportunities to not just the, let's say, big companies, but also like small companies or even universities to build up their CubeSat or NanoSat to work on something new, like more research on this. So in this kind of area, I think it's really helped build up the space economies. So let's talk about the other places as well that they're using the communication network. So I think like we all know GPS, but like Japan, they also have their own satellites, like the navigation location system, the QANSI, the QCSS as well in Japan, or like another example for the communications here in Asia gonna be Thailand, that they have the Thaicom satellite that provide the communications and broadcasting services in the Asia Pacific region as well. So yeah, we can see that not only the, let's say, the biggest players like the US, NASA's, or China's, we also have like more and more players like joining the force of the space ICT.
Great. Despite the fact that these technology have been used to do huge tasks, I am confident that there must be drawbacks and threats. So what are the potential threats and vulnerabilities connected with space-based ICT, and how can we ensure its security and sustainability as we focus more on it?
Okay, so I think one of the biggest like potential threats and vulnerabilities regarding to the space like ICT is I think we can talk about like the cybersecurity. All these satellites, all everything that we have used is based on digital system. It's basically computers floating around in space. So yeah, back before it just like back and forth communications. But when we have more advanced technology, it is do things more than that. It can move, it can point it, we can navigate it. So let's say if they're gonna be someone who do the cyber attacks on this satellite, it gonna cost like a lot. Like it could bring the satellite to be on collisions with other satellites. That is the physical vulnerability that we need to find a way to prevent. And of course, for non-physical things, we have like tons of like information up in the space. So another vulnerability is this could lead to, let's say, data breaches, or it could lead to manipulations of vital space systems. And another things not like digitally related, like when we have a lot of like satellites orbiting space, of course, it's gonna get more congested. Like the other things is about the satellite traffic. How can we like manage the traffic like for the satellites and also the space station as well, to reduce the risk of like having them as the space debris in the futures. And of course, this lead to how are we going to work on this? We need to have like, let's say, kind of security standards, kind of same of the technologies world back on Earth, the way we live. So we have like security standards. We have the organizations that working day and night on the vulnerability loophole on the software systems to ensure that if there are any vulnerabilities, we need to prevent at day zero. So we need to also implement this kind of like regulations on structure standards as well in the space ICT world. And of course, like talking about the congestion traffic, I think it's come back to the regulations as well, to how satellite like development um, would need to be going. So we cannot just send things up into space. We need to think about the whole life cycles of it, like how because we need like to sustain, right? We cannot just have like everything congested up in the skies. We need to take the use of the space ecosystem for quite a long time. So we need to take, like, let's say, the satellite end of life into our planning as well. So from the start and to the end, how the satellite gonna end? Are they gonna deorbit? Are they gonna be fly and have head like back to Earth? So we need to consider that as well.
With that answered, we have reached end of this episode. Before moving to the end, we would love to know your thoughts about the podcast series.
Okay, sure. For this podcast series, Tech Innovators, I think it's a really good stage, like 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 when you like inviting guest speakers, like talking about the various themes of technology. So like today I'm talking about space ICTs, and I have like listened to you like podcast as well. You have like talking into like various points of like the technology ecosystems. There are a lot of things that happening around technologies world, and I think it's really like good things for the audience to have the guests to share their experience and to see like how all aspects and all domains of the technology's roles in the present day are working right now. And I think the audience will also learn more about like how the things gonna move forward in the future, how the things gonna connect together in the future in the technology world as well.
Thank you, Mr. Pires, for joining us today. And I'm certain our listeners have gained a lot on the topic we have discussed today. Please rate and review our program if you appreciate it. We have several more episodes planned for you. So stay tuned by following us on Spotify, Google Podcast, Apple Podcast, SoundCloud, Radio Public, Breaker, and YouTube. Thank you for listening, and we will see you in future episodes.